In this video, we're going to learn how to solve logarithmic equations. Now, the key to solving logarithmic equations is to change it to its exponential form. Since you know that a log is equal to the exponent you raise the base to get the inside number, we can use this to our advantage. So we'll see here that 4x minus 7 should equal 3 to that second power, since 2 should be the exponents. Now, 3 squared is 9, so I have 4x minus 7 is equal to 9. I can add 7, give me 16, then divide by 4, which gives me 4. So my solution is 4. Now, one thing you should do quite often when you're dealing with logarithmic and exponential equations is to check your answer, since sometimes changing the form could change the potential answers you get. So just to be safe, let's check our answer to see if it's extraneous. We have log base 3 of 4 times 4 minus 7 equals 2. 4 times 4 is 16. 16 minus 7 is 9. And 2 is the power you raise 3 to get 9. So yes, log base 3 of 9 is 2. So that does work. So just double checking, but that is a solution. Now down here, our base happens to hold the variable this time, but rewriting this in exponential form would give me 64 is equal to x to the second power, with that 2 being the exponents. Now I will take the square root of both sides. This gives me 8 is equal to the absolute value of x. To get rid of the absolute value, I'll take plus or minus 8 as my two solutions. Now, one solution I'm going to throw out right away is this negative 8, since we can't have a negative base for a log. That cannot work. But 8 seems to be a correct solution. So if I check this, I have log base 8 of 64 is equal to 2. I do know that 8 squared is 64, so that should be a correct statement as well. So my solution would be x equals 8, but not x equals negative 8, since I can't have a negative base down here. Next up, I have e to the 2x plus 5. Now, while this is an exponential equation, it goes over one technique I want to talk about right now. Is if it is an exponential form and your variable's in the exponent, you need to switch it to a logarithmic form. So since we have a natural base here, switch into a logarithmic form, we'll have 2x plus 5 equal log base e of 8. Now when you have a base e, that's also known as your natural base. So that's 2x plus 5 equals natural log of 8. Then we'll subtract 5. We get 2x is equal to natural log of 8 minus 5. Divided by 2, we get natural log of 8 minus 5 all over 2. Now, if this was an application, you would need to know how to get an approximate solution for that expression. So that's where we use our calculator in this instance. We have to plug in the natural log of 8 minus 5 all divided by 2. Its approximate solution to this problem would be x is approximately negative 1.46. Now you're going to notice that I didn't check my solution here. Well, I don't have a domain restriction with exponential functions, so I shouldn't normally come across any no solution answers. The only thing I need to be worried about is if my exponential would ever equal a negative number. I know that can't happen. So in this case, I do not need to check my solution. I can just move forward. So you'll see here, this is an exact solution versus an approximate solution. Depending on the context of your question, you should know which one to use. Next up, I have 2 times 10 to the 2 minus x. So I do have another exponential equation, but you want to make sure it's by itself before you switch its form like we did here. So you see this 2, I'm going to divide each side by 2 before I try to switch forms, because now that I have 10 to the negative 2, 10 to the 2 minus x, I can rewrite this as 2 minus x is equal to log base 10 of 5 halves. Now we have a base 10 that's known as the common log. So I can write this as 2 minus x is equal to log of 5 halves. Then I could subtract 2, get negative 2 plus log of 5 halves, and then divide by negative 1 to give me x is equal to 2 minus log of 5 halves. Now I can plug this into my calculator to get an approximate solution, so I'm going to do so. I'll have 2 minus log, the common log in comparison, of 5 halves, which is 1.6, I'll put O2. So I have my approximate solution versus my exact solution. Now let's get back to logarithmic equations. I just want to make a little detour to make sure you knew how you can also switch it to the other form to solve your equations as well. So now let's look at log base 3 of x squared plus 1. Now switching to its exponential form, I'll get x squared plus 1 is equal to 3 to the second power. The trick is always that the log equals the exponent. So that should always become the exponent, and the base of your log should be the base of that number. Now I get x squared plus 1 is equal to 9. Subtract 1, you get x squared equals 8. Then taking the square root of both sides, I get absolute value of x is equal to, simplifying the square root of 8, 2 square roots of 2. So x is equal to either positive 2 square roots of 2 or negative 2 square roots of 2. So we'll check both solutions. So log base 3 of 2 square roots of 2 squared plus 1 gives me log base 3 of 8 plus 1. This gives me log base 3 of 9. That certainly is equal to 2. So positive 2 square roots of 2 works. Plug it in the other number. I get log base 3 of negative 2 square roots of 2 squared plus 1. This gives me log base 3 of, again, positive 8 plus 1. So log base 3 of 9 is indeed equal to 2, so they both work as solutions. In this case, we had 2 solutions. Next up, I have log base 4 of x squared plus x plus 4 is equal to 2. So rewriting this in exponential form, I have the inside of my log, x squared plus x plus 4 is equal to 4 to the second power. Since the log is equal to the exponent, the 2 should become the exponent. Squaring the 4, I get x squared plus x plus 4 is equal to 16. Subtracting 16, I get x squared plus x minus 12. And then I can factor that quadratic to give me x plus 4 times x minus 3. So my 2 solutions are negative 4 when I subtract 4 from the left equation, and positive 3 when I add 3 to each side of the equation. We should still check our solutions. So I get log base 4 of negative 4 squared plus negative 4 plus 4. So negative 4 and 4 cancel, leave me with log base 4 of 16, which is indeed 2. So x equals negative 4 does work. And then my other check, log base 4 of 3 squared plus 3 plus 4 gives me log base 4 of 12, not 12, 9 when you square 3. 9 plus 7, which is 16, which also equals 2. So both solutions work. And that is how you solve logarithmic equations.